Definition of UHT milk based on Food Regulation 1985. Ultra-high temperature milk or UHT milk should be milk which has been subjected to treatment by being retained at a temperature of not less than 135 Celsius for at least 2 seconds to render it commercially sterile and immediately aseptically packed in sterile containers. They should be written in the label on a package containing ultra-high temperature milk or UHT milk.
Processing of UHT milk. The first process is preheating with or without a holding time. The preheating stage takes the temperature from 5 degrees Celsius to 90 degrees Celsius using the hot milk pasteurization as the heating source in tubular or plate heat exchangers. This heat regeneration step is very important for the energy efficiency of the UHT plant. Secondly, homogenization for indirect systems. The final heating step to the required sterilization temperature is achieved by one of two major types of heating, the so-called direct and indirect systems. Indirect systems employ heat exchangers in which superheated steams heat the milk indirectly through a stainless steel barrier in the form of either a tube or a plate. The third process is heating to sterilization temperature. Direct systems heat milk from preheat temperature to sterilization temperature in less than 1 second, whereas indirect systems can take several seconds to minutes. The direct systems produce much less chemical change in the milk constituents than the indirect systems.
Step 4. Holding at sterilization temperature. When the sterilization temperature is reached, the milk enter a holding tube. The temperature of the milk and the time it takes to pass through this holding tube are the nominal conditions, which are usually stated for UHT process, which is 140 degrees Celsius for 5 seconds. Many chemical and microbiological changes occur in the heating step immediately after the sterilization step. Step 5. Initial cooling. The initial cooling of the product in direct system is achieved very rapidly as it is passed through a vacuum chamber which removes the water condensed into the product. Then, it returns the temperature of the product to close to the temperature from which it was heated, usually around 75 degrees Celsius. In the final cooling step in direct system and in both cooling steps in indirect system, the heat from the hot milk is transferred to the cold milk in the preheating or heat regeneration step.
The next step is homogenization and final cooling. When fat is present in the product, such as in whole milk, a homogenization step is included. This is carried out at 60 to 70 degrees, either before or after the sterilization step. If the homogenizer is downstream of the sterilization step, it must be aseptic as no bacteria can be introduced after sterilization. This clearly puts a high demand on the plant operators to ensure the homogenizer is aseptic, and for this reason, where possible, homogenization is carried out before sterilization. However, it has been found that milk processed by a direct heating process has to be homogenized downstream to break up aggregates of protein, which form during heating and cause an astringent taste in the milk. The last step is aseptic packaging. The aseptic packaging step is a crucial one. The product must be transferred after cooling to the final package and the package sealed without introducing even one bacterial cell. In most commercial plants, the product is held in an aseptic tank before it is sent to the aseptic packer. Various packaging types are available, but the most common are paperboard and multi-layered plastic. The packages are sterilized before being filled, usually with hot hydrogen peroxide followed by hot air to remove residual peroxide.
Direct heating. Direct heating of milk is heated by direct contact with steam of potable or culinary quality, which could be obtained from potable water. The advantages is it is held at elevated temperature for a shorter period of time. That means less damage. There are two types of direct heating, which is injection and also infusion. Injection. Injection is when high pressure steam is injected into preheated liquid by a steam injector, leading to a rapid rise in temperature. After holding, the product is flash cooled in a vacuum to remove water, equivalent to amount of condensed steam used. The advantage of this method is fast heating and cooling, while the disadvantage is potential for flavor damage. Next, infusion. Infusion is the liquid product stream is pumped through a distributing nozzle into a chamber of high pressure steam. This system is characterized by a large steam volume and a small product volume, and it is distributed in a large surface area of product. The product temperature is accurately controlled via pressure. The advantage of this method is instantaneous heating and rapid cooling, no localized overheating or burn-on, and also suitable for low and higher viscosity product.
Now I'm going to talk about UHT treatment, indirect heating. Indirect heating is performed by plate or tubular heat exchangers in which heating medium is steam or superheated water. Heating medium and product are not in contact but separated by equipment surfaces. Indirect heating also has low heat transfer rate and higher rate of deposition over the surface that need frequent cleaning, but less processing and operational costs and require less control. Plate heat exchangers able to withstand high temperature and internal pressure, provides more surface area for heat transfer, low cost and simple design, easy inspected and allow potential regeneration. In and outlets allow the fluids enter and leave the heat exchangers, gasket plates to separate fluids and prevent them mixing, movable cover, fixed cover, carry bar, clamping bolts, and guide bar. Fluid 2, which is a hot media, enters a heat exchanger through the hot media inlet. Gasket direct fluid 2 as it flows through the heat exchanger. Each plate has an alternating gasket pattern. Fluid 2 flows into space between the pair of plates. The process continues so that each second set of plates is filled with fluid 2. At the same time, the cold medium, which is a fluid 1, enters the heat exchanger to the cold media inlet. The gaskets are positioned to allow fluid 1 to flow into the space where no fluid 2 is present. Flow between neighboring plates ensures the two fluids can transfer heat through the heat exchanger plates, but they do not come to direct contact with each other. After heat has been transferred between the two fluids, the fluids exit the heat exchanger through outlets.
Packaging. Aseptic filling. Aseptic filling or processing is a process in which sterilized product packaged or filled in a sterile container under aseptic or sterile condition. Basic operation in aseptic packaging: heating the product to sterilization temperature, maintaining the sterility of the products till they are cool or packed, and filling into sterile containers and sealing aseptically. Next, advantages of aseptic processing: improved texture, color, and extended shelf life. A wide variety of packaging material of various sizes can be used, and minimum handling of container during sterilization process. Tetra Pak aseptic filling machine is one of the technology used in processing and packaging for UHT milk. 3 major steps for aseptic packaging for UHT milk. First, aseptic packaging system use hydrogen peroxide at a concentration 30 to 35%. Second, sterilization of packaging material using hydrogen peroxide followed by ultraviolet radiation. And third, dry heat 176 to 232 degrees Celsius in the form of superheated steam or hot air used to sterilize the packaging material and equipment.
That's all from us. Thank you.